Today, let's talk about the elusive particle physicists knew had to exist, but took half a century to find, the God particle. The official name of this particle is the Higgs boson. This discovery is considered one of the greatest scientific achievements of the 21st century. So, let's dive into what it is and why it is so important. First, let's discuss the origin of the name God particle. The nickname was coined by Nobel Prize-winning physicist Leon Lederman, who originally wanted to title his book The Goddamn Particle. However, his editor found it to be inappropriate, and the name was eventually changed to the God particle, which caught on and became widely used in popular culture. Now, what is the Higgs boson? In simple terms, the Higgs boson is a subatomic particle that gives other particles mass. Before the discovery of the Higgs boson, scientists were unable to explain why particles had mass. According to the standard model of particle physics, the Higgs boson is the only particle responsible for giving mass to other particles. The discovery of the Higgs boson was made by the Large Hadron Collider, LHC, at CERN, the European Organization for Nuclear Research. The LHC is the most massive particle accelerator ever built and is located in Geneva, Switzerland. It consists of a 27-kilometer ring of superconducting magnets that accelerate and collide particles at nearly the speed of light. In 2012, two independent experiments at the LHC, CMS, and ATLAS discovered the Higgs boson. The discovery confirmed the existence of the particle predicted by the standard model of particle physics. Now, let's get into the nitty-gritty details of the Higgs boson. The Higgs boson is a type of particle that is part of a group called bosons, which are named after an Indian physicist Satyendra Nath Bose. Bosons have a specific type of behavior, and the Higgs boson is a special type of boson with zero spin. This means that it doesn't spin around like a top like most particles do. Instead, it behaves more like a wave. The Higgs boson has a mass of around 125 billion electron volts. Now, 1 electron volt is the amount of energy gained by an electron when it moves through a potential difference of 1 volt. To put the mass of the Higgs boson into perspective, it is approximately 133 times heavier than a proton, which is a subatomic particle found in the nucleus of an atom. The Higgs boson is a very short-lived particle with a lifetime of about 10 to the power minus 22 seconds. It decays rapidly into other particles, making it challenging to detect. Scientists at the LHC detect the Higgs boson by looking for its decay products. It typically decays into quarks, but it's also been found to decay into a completely different class of particle called muons, a particle that is similar to electrons but way more than 207 times as much. This is a strong indication that muons, like quarks, really do get their mass via the Higgs mechanism. Do you know that there are theories which say that the God particle was the fuse that started the Big Bang? Well, these are just theories for now. But there is a very interesting research which suggests that, if the Higgs had a significantly greater mass than it does, the universe might have undergone catastrophic collapse before it had a chance to get going. This may indeed have been the fate of other parts of the multiverse, but thankfully not our own. If that theory is correct, we can thank the Higgs boson for our very existence. So, that was it for this video. Thanks a lot for supporting.